So, although we want to know about the biosynthesis of amino acids and the degradation of amino acids, it's also important to think about what can you make from an amino acid and what basically how are amino acids utilized in the body or utilized in a cell when it is not for the purpose of synthesizing a protein. So, for one, heme, the molecule that is involved in um, transporting oxygen, is synthesized in the liver and bone marrow from succinyl-CoA and the amino acid glycine. There are a couple of different neurotransmitters that are synthesized from amino acids, likewise hormones, and finally nitric oxide, which is a vasodilator and helps blood flow. Now, I'm going to go through a couple of these as just examples here. So, first of all, here is basically a rundown of heme biosynthesis. We've got our starting molecules of glycine, and we've got our heme molecule that we're arriving at. Now, succinyl-CoA and glycine combine in the mitochondria to make ALA. That ALA is transported out of the mitochondria into the cytosol until ultimately we get to a point where we're bringing back this protoporphyrin 9, and that protoporphyrin 9 is finally basically our last step in, or prior to getting the iron ion into the center of that heme ring. So what I want you guys to be focused on and familiar with is the important step is the synthesis of this ALA, because when you have two of those ALA molecules, you're able to make up this porphyrin, which that PBG is one of the basically 4 different parts that make up that heme ring. For some reason, I've always looked at this and I've always thought that it looks like a monopoly houses, basically. So you've got this nitrogen right here, which is going to be one of the points, or one of the 4 points that coordinate that iron ion in the center of it. So you have to put together 4 of those molecules in order to ultimately produce this heme molecule right here. Next up, with respect to synthesizing a neurotransmitter, well, we have glutamic acid that in one simple step, we're just decarboxylating it. Glutamic acid decarboxylase is what catalyzes that reaction. That is going to produce the neurotransmitter GABA. Finally, well, maybe not finally, but another pair of amino acids actually that are involved in synthesizing hormones are phenylalanine and tyrosine. This is a metabolic pathway in which we're going from phenylalanine. So basically, if you are contributing phenylalanine or tyrosine, you're ultimately going to go through to produce L-DOPA, dopamine, which is a precursor for noradrenaline, and noradrenaline is a precursor for adrenaline. So that's basically your kind of quick pathway. The key there, or one of the important parts about that, is look at and compare phenylalanine and tyrosine. They both have your rings. Tyrosine has a hydroxide group there, which, well, you add another hydroxide group, and now all of a sudden your L-tyrosine becomes L-DOPA. Then we are going to decarboxylate L-DOPA to give you dopamine. Then what you're going to do is you're going to add the ascorbic acid plus O2 in order to produce our, well, you're just adding an OH group right here, making that noradrenaline. And then after that, you're going to add a methyl group onto your nitrogen of noradrenaline to make adrenaline. Now, the last amino acid that you can use to, or that we're going to talk about with respect to synthesizing something is, well, this pathway right here. Okay, first and foremost, some of the things I want you to kind of recall: ornithine, going to citrulline with the help of carbamoyl phosphate. Well, this is our urea cycle. Now, if you remember, ornithine is an amino acid, and that amino acid, you're going to combine that with a CN group or a carbonyl, carbon, and the nitrogen, and you're going to make that citrulline. Well, continuing on through that pathway, one of the intermediates in the urea cycle is arginine. Arginine is an amino acid, and as it turns out, arginine can basically skip across the urea cycle to be immediately converted into citrulline. And in that process, one of the things that you're going to produce is nitric oxide. Well, nitric oxide, NO, is a vasodilator. That's something that if you know anyone who's like a fitness fanatic, one of the things that they're going to, one of the amino acids and nutritional supplements that they probably take is arginine, or possibly another urea cycle intermediate, because this is supposed to help blood or increase blood flow, so you know when they're working out it's a better workout or something like that. At any rate, these are not the only things that you can synthesize from amino acids. This is just a sort of a snapshot of these different molecules and different compounds that are used. At any rate, thank you very much, and I hope you have a good one.